Welcome to this Sherman and Reilly instructional video about sizing the tensioner unit for stringing overhead distribution conductor using the tension method. Through this video, you will learn about the four main factors to consider for your overhead pull. You will also learn generally how to determine the right size tensioner and bullwheels for stringing overhead conductor under tension. We'll cover a lot, so feel free to pause, rewind, and watch again to catch it all. The main objective in your conductor pull is to install the conductor safely and economically, and in a manner that does not damage the conductor or structures or cause any other issues. Although this video is a distribution job example, the IEEE Guide to the Installation of Overhead Transmission Line Conductors is a good industry reference standard for overhead line work and sizing equipment and blocks. Sherman and Reilly recommends following these guidelines and following your company's work practice guidance. So now let's look at the four main equipment components needed for installing new conductor under tension. First, there is the tensioner. Secondly, there is the puller. Thirdly are the blocks. And lastly, there is the pulling line, which is used to pull the conductor. All four of these components must be appropriately sized to do the job without fail and without damaging the conductor. In this video, we will consider and cover the first item, the tensioner or tensioning unit. Of the equipment components needed, the tensioner is the easiest unit to size. This is the unit that rolls out the conductor while still holding it under tension so the conductor doesn't drag on the ground or roadways or get damaged. It's common to use a bullwheel tensioner for this, like a Sherman and Reilly BWT 1424H. So, let's figure out what size tensioner we need. This is easy. With just a little bit of math, we can calculate the amount of tension that is required to hold the conductor across the length of a single average span length. This is known as static tension and is represented as T1. To calculate the static tension, or T1, first we need to know how much the conductor weighs. A smaller conductor will obviously weigh less and need less tension. A larger diameter conductor is heavier and will require more tension to keep it aloft. Once we have the weight of the conductor, we can easily calculate the static tension, or T1. Here is the formula for calculating T1. W equals the weight of the conductor per unit of length. We'll use feet, so weight per foot. L equals the average span length, the distance between the poles or structures. D equals the planned stringing sag, not the final sag, but just the sag during the installation of the conductor. 8 is a constant. So first, we need the weight of the conductor. The conductor manufacturer typically provides this in a specification label on the side of the conductor reel. A quick look at the conductor manufacturer's information about the conductor will provide the weight of the conductors for a specified length. For our example, let's say we're using 795 Drake A CSR, which is pretty common. The label lists that Drake weighs 1,093 pounds per 1,000 feet. Take 1,093 pounds and divide that by 1,000, or move the decimal 3 places to the left, and we get a weight of 1.093 pounds per foot. So we now have the weight of the Drake conductor per foot, 1.093 pounds per foot. Next is the average span length, which is represented in the formula by the letter L. For our example, let's say our average span length L is 250 feet. And our target stringing sag, represented by the letter D, is 10 feet between structures, because we are in a busy area and need to keep this work up and out of the way. So back to the formula. T1 equals the weight per foot times the average span length squared, which is then divided by 8 times your stringing sag. So we take 1.093 pounds per foot, multiply it by 250 feet squared, and divide that by the constant of 8 multiplied by the installation sag of 10 feet. So that's 8 times 10 or 80 feet in this example. So the T1 calculates out to be 854 pounds. So revisit the math. To calculate the T1 value, take the weight of the conductor per unit of length multiplied by the length of a span squared, and divide by 8 times the amount of installation sag. Bam! You have just calculated T1, which tells you the size tensioner you will need. One that can hold back tension of at least 854 pounds of tension on the conductor while it is pulled out. Now that you know the size of the tensioner needed for this job, it's easy to determine which Sherman and Reilly products can handle this tension, like Sherman and Reilly's BWT 1424H. But there are two more things you should consider. First, the diameter of the bullwheels needs to be large enough to not damage the conductor, and there's an easy calculation for this. To figure out the size bullwheel needed for your conductor, use this easy formula. Take the conductor diameter and multiply it by 39. Then subtract 4. The diameter of the Drake ACSR conductor is 1.107 inches. Multiply this by 39, then subtract 4 to get the minimum recommended size bullwheel. So based on this calculation, you need bullwheels that are a minimum of 39.173 inches for this size conductor. The 42-inch bullwheels on the BWT 1424 have a bottom of groove diameter of 40.73 inches, which you can find on our website. So this bullwheel size is a good fit for this conductor. The next thing to check is to make sure the grooves on the bullwheel are large enough. Check that the groove radius, which is half the groove diameter, is large enough to accommodate the conductor without pinching or damaging it. Another easy multiplier, and you have your answer. Take the diameter of the conductor, which again, for the Drake is 1.107, and multiply it by 0.525. This means that the bullwheels should have a groove radius of at least 0.5812 inches. The BWT 1424 has a groove radius of 0.6 inches, which can also be found in the specifications for the equipment on our website. After these calculations, you know that the BWT 1424 bullwheels have a large enough outside diameter, and that the bullwheel grooves are large enough to accommodate the conductor. You've just finished sizing and confirming that you have the right Sherman and Reilly tensioner for your job. This concludes this Distribution 101 video, Sizing the Tensioner Unit. Thank you for watching, and look for our other future Distribution 101 videos. To learn more about Sherman and Reilly equipment, visit Sherman-Reilly.com. Thank you for watching.